Alright, partial fraction decomposition. This is actually an algebra topic that you can look up online. If you have no idea about partial fraction decomposition and what it means, how to do it, I would suggest trying to find an algebra video on how to do partial fraction decomposition before you actually spend too much time on the calculus. Because if you're messing up with the actual algebra on this, there's no way to get the calculus part right. So what is partial fraction decomposition? Well, you learn in algebra, like let's say I had 1 over x plus 2 minus 1 over x plus 3. You learn in algebra that usually you wouldn't want to leave an answer like that. How would it be left? You'd get a common denominator of x plus 2 times x plus 3. Then, to put the numbers up here, you'd have to say, okay, what's in my common denominator that's not right here? X plus 3. X plus 3 times 1 is x plus 3. Then you have a minus 1 here, so you need to look at your common denominator. It doesn't have an x plus 2, so you got to say negative 1 times x plus 2. So negative x minus 2. Alright, and so you would learn that your answer was 1 over x plus 2 times x plus 3. Now that's just all algebra. I haven't really done anything there. I've just combined two terms. And I'm going to go even further. What would that be equal to? 1 over x squared plus 3x plus 2x, so that's plus 5x plus 6. Alright, and so I went through all of this, something that you learn in college algebra, just to show you that, what if I had this term here but I didn't know any of this other stuff? 1 over x squared plus 5x plus 6. But I didn't know that that was the same thing as these two terms. It's not always just going to be a 1 here and a 1 here. Notice there's a minus there. Where does that minus come from? That minus, does it just magically occur? No. How would you be able to take this and break it back into this? That's partial fraction decomposition. And this is one of the easiest examples that I could do. The way that you do that you figure out how to break it up into its small pieces like that, is by taking first and factoring the denominator. The types of factors that you get will depend on how you set the problem up after this step. So if you see that factors into x plus 2 times x plus 3, then we can have different types of linear factors. We could have the same type of linear factor, meaning if this was x plus 2 times x plus 2, that would be x plus 2 squared, right? That's called a repeated linear factor. So we can have linear factors. We can have repeated linear factors. We could have quadratic factors. Or we could have repeated quadratic factors. Yes, there's all other types of factors we could have, but these are the easiest that we can deal with, repeated quadratic factors. Now, with linear factors, if the factors are all different, and even if it was an x to the first there, that's still a linear factor. It doesn't have an x to the first there, but if it was a factor, that's still a linear factor. With those, the way you set those up, you take each linear factor here, you'll say a over the first one, plus b over the second one, and then again if there was some other number there, or some other factor, you just put plus c over the next one, plus d over the next one, and so on and so forth. As long as they're all different factors, this is how you set up the second part of the equation. So up here what I would do is I'd say that equals a over x plus 2 plus b over x plus 3. I'm trying to figure out these numbers up here. These are my variables really in my problem. I'm trying to figure those out, so that when I add them together, I would get this, which is this. All right. Now, if I have repeated linear factors, let me just show you, before I work this out completely, which this is, again, this is the easiest example I could possibly do, so it may not be the best one to work out. But let me show you how you set up repeated linear factors. Like, say that you had 1 over x plus 1 squared times x. The x plus 1 is repeated. So the way that you need to set that up, that would be a over x plus 1 plus b over x plus 1 squared plus c over x. So if that was cubed, you would have x plus 1 squared, and x plus 1 cubed. You have to just, the more it's repeated, the more you have to have. Quadratic factors would be, what if I had 1 over x squared plus 2? There's no way to factor x squared plus 2, so I'm going to have to make it more than just x squared plus 2. Maybe x squared plus 2 times x plus 1. So your what you put up top changes for a quadratic like that. You put ax plus b, so variable x plus variable over the quadratic part, plus, now I have to go to c, so it's c over x plus 1. Alright, now if you have repeated quadratic factors, if it's repeated quadratic factors, like say I had 2x over, let's say x squared plus 1 times x minus 1 times x squared plus 3 squared. Alright, so here's the way my equations will need to be. Ax plus b over x squared plus 1 plus c over x minus 1 plus, now here's where the repeated quadratic comes into play, dx plus e over x squared plus 3 squared plus fx plus g over x squared plus 3. So notice you have to do it twice, just like with the linear, how you had to do it twice, once with the second power, once with the first power. Now actually solving for these things on the top, these letters on the top, that's what we're trying to do, because then we can break it up into small fractions like this. Okay, so let me go back to the super easiest example I was working on, and then I'll work just a couple examples as fast as I can to give you an idea. I'll get you to catch on to this method, because it does take a little practice, just like anything else. It's not just something you look at and figure out. Alright, so if I have this fraction and the denominator will factor, then I can set it up like this. So I'm going to rewrite that right there down here. I had 1 over x plus 2 times x plus 3 equals a over x plus 2 plus b over x plus 3. Now, once you get to this step, you do the same thing regardless of what your equations on the right side are. You multiply the entire equation by the common denominator. So what that's going to do, if you multiply the common denominator times every term in the equation, on the left side of the equation, that's always going to give you the numerator. It just so happens this numerator is 1, the easiest example possible. So you could have a string of variables and terms up here, but this one is just 1. Equals. Now when you say this common denominator times the first term, the x plus 2's would cancel out and leave you with a times x plus 3. When you say this common denominator times this term, that's going to leave you with, you got plus b times x plus 2. Alright, so x plus 3, x plus 2, you got this equation now. Now there are a couple ways you can solve this equation, but the way I'm going to show you is the preferred way most of the time. Okay, so what you want to do is you want to multiply out the right side. So you'll have ax plus 3a plus bx plus 2b. Now group your common terms. So you have an ax and you have a bx. You also have a plus 3a and a plus 2b. Alright, so now what you want to do, once you have your common terms grouped together, on ones like this, these two common terms here, you can factor an x out. You can't with these two, but you can with these two. So 1 equals a plus b times x, and then you have plus 3a plus 2b. Alright, and so what this tells you is you compare the coefficient of x to the first on this side with the coefficient of x on this side. There is no x on this side because this is one of the easiest possible examples. So this coefficient, this a plus b, is equal to 0 because there's no x to the first over here. So we have the equation a plus b equals 0. Now you look at the constant terms. 3a plus 2b. 3a plus 2b, all of the constant terms on the right side must equal the constant on the left side. So 3a plus 2b must equal 1. Now we have a system of equations. How do you solve a system of equations? You can use substitution, you can use elimination, you can use matrices, whatever way you know how to solve. What would I suggest? On one like this, I would use substitution because we have a plus b equals 0. So a equals negative b. What does that mean? That means where I have an a, I can plug in a negative b. So 3 times negative b plus 2b equals 1. So what is that? Negative 3b plus 2b equals 1. So combine those two, so negative b equals 1. Divide both sides by negative 1, b equals negative 1. So b equals negative 1. What does a equal? A is equal to negative b. So a equals positive 1. So I've solved this system of equations. A is positive 1, b is negative 1. So go up here where I have this written. And so this right here I can now rewrite with numbers in here. Just this right side. So a is positive 1, b is negative 1. So that 1 over x squared, what was it, x squared plus 5x plus 6 is equal to 1 over x plus 2 and plus negative 1 over x plus 3. Or you could write that as 1 over x plus 2 minus 1 over x plus 3. And so you may be thinking, well, why is that such a big deal? Why is that algebra such a big deal? Because if I had the integral of this, dx, then that would be equal to the integral of this, dx. I may not can integrate this, but by breaking it up into its two partial fractions, I can integrate each one of these separately. Because if I let the denominator be my du is 1. So this is natural log absolute value of x plus 2 minus natural log absolute value of x plus 3 and plus c. And I could even combine this, right? Because we know there's a rule for logarithms that says if you subtract logarithms, that's just like dividing. So this is equal to the natural log of the absolute value of x plus 2 over x plus 3 plus c. All right, let's practice with another partial fraction. So the first thing that we need to do is we need to, I guess, recognize that it's a partial fraction. Let's say I had the integral of x plus 2 over x squared plus 5x dx. So notice I can't divide the bottom into the top. You know, when you can do that, you divide. You use long division. When you can't, then you need to try to use partial fractions to split it up. So let's see. I can factor this denominator. So I first just want to work with the algebra. So I'm gonna rewrite this down here, x plus 2 over, and now factor out an x. That's x times x plus 5. So this is just linear factors. So what is this equal to? It's equal to a over x plus b over x plus 5. Multiply times the common denominator, x times x plus 5. That's going to leave me the left side with the numerator, x plus 2. The right side is now going to be a times x plus 5 plus b times x. All right, multiply out the right side, ax plus 5a plus bx. Group the two like terms. Here it's just ax plus bx. And then factor the x out there. So that's going to be a plus b times x and plus 5a. Now once you factor the x out of every set of terms that you can, Now you compare the coefficient on the right side with the coefficient on the left side. So for the x to the first term, a plus b is going to be equal to 1. All right, with the constant terms, there's only one constant term, 5a. 5a is going to be equal to 2. All right, so solve. What is a equal to? A equals 2/5. So if a is 2/5, 2/5 plus b equals 1. b equals -3/5. Subtract 2/5 from both sides. No, it's a positive 3/5. Subtract 2/5 from both sides. All right, so a is 2/5, b is 3/5. Let's rewrite this right side here, up here by my integral. This is the integral of a was 2/5, so it's 2/5 over x plus b is 3/5. 3/5 over x plus 5 dx. This first integral is a natural log integral. The second integral is a natural log integral. So what is it? That's 2/5 times the natural log of x, absolute value of x, plus 3/5 times the natural log absolute value of x plus 5 plus c. So you could rewrite that as, since there's a plus here, you could write it as a product. Before you do that, though, you would want to move your powers in. You want to use a power rule. So this is the natural log, the absolute value of x to the 2/5, plus the natural log absolute value of x plus 5 to the 3/5. And so now we can apply the product rule. So it's equal to the natural log absolute value of x to the 2/5 times x plus 5 to the 3/5 plus c. No, don't multiply any of that stuff in. Leave it like that. Okay. So let me work one now that has a quadratic. Let's say that I had this one, the integral of 6x over x cubed minus 8 dx. No integration I could do, it doesn't fit any rules, so I need to take this and work some magical algebra to it and see if I can integrate it. Okay. So, how does this factor? The denominator has the factor to be able to use it, unless it's just a quadratic that won't factor. That's a difference of 2 cubes, right? So everyone remembers how to factor the difference of 2 cubes. If you don't, what you can do is your a is x and your b is 2, because what are you cubing to get that? What are you cubing to get that? Then it's a minus b. All right, then what goes over here? A squared all right, plus ab plus b squared. So again, it's a minus b times a squared plus ab plus b squared. That's just how that factors, right? You can multiply that back in and you'll get a cubed minus b cubed. So 6x over x cubed minus 8 is equal to 6x over, it's going to be x minus 2 times x squared plus 2x plus 4. Now, this right here is not going to factor. If it did, then it wouldn't be the difference of 2 cubes. So this is a quadratic. So what you have to do, that's going to be equal to a over x minus 2, because it's linear, plus bx plus c over x squared plus 2x plus 4. Now multiply this through by the common denominator, x minus 2 times x squared plus 2x plus 4. That's going to leave me with 6x equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Okay, so that's going to equal ax squared plus 2ax plus 4a. And now you need to fold that out. It's going to be plus bx squared minus 2bx plus cx minus 2c. Alright, so now combine like terms, or not combine like terms, but group like terms and factor the x's out where you can. So you see this is an ax squared and that's a bx squared. So that's going to be a plus b times x squared. This is a 2ax and a minus 2bx. So you can have 2a minus 2b times x. I'm just factoring the x out of those two and writing the coefficients in front. And then I left the c out, didn't I? See, that's plus cx. So I need that c in there. So plus c times x. So don't forget that this term, and this term are all similar, so they must be grouped together. So I did that, I did that. That only leaves me with 4a minus 2c. Okay. So now, to solve this for a, b, and c, use the coefficients. So a plus b is equal to, what is the coefficient of x squared? There is no x squared, so it's 0. 2a minus 2b plus c must be equal to 6. And 4a minus 2c, the constants, must be equal to 0. Alright, so now we have this system of equations. We have this equation that has a, b, and c. We have this equation that has a and b. And we have this equation that has a and c. So what you want to do is get rid of this c right here so that you'll have two equations with just a and b. So to do that, I need to solve for c. So negative, or you could move the 2c over and flip it around and get 2c equals 4a. So what is c equal to? C is equal to 2a, right? So where you have a c, put a 2a. So 2a plus 2a, that's 4a minus 2b equals 6. And a plus b equals 0. So if that's the case, either use elimination or substitution. On this one again, if you just say a equals negative b, then right here, where you have an a, right here, sorry, you can plug in a negative b. So that's 4 times negative b minus 2b equals 6, or negative 4b minus 2b equals 6, negative 6b equals 6. So b equals negative 1. If b is equal to negative 1, what is a equal to? Because it's negative b. A equals a positive 1. If a is a positive 1, then we have 4 minus 2c equals 0. Right? If I plug in a 1 right there. So 2c equals 4. Right? Divide both sides by 2. C equals 2. So I've solved for a, b, and c. Right? A, b, and c. All these that I need. Alright, so a was equal to 1. So our integral is going to be 1 over x minus 2. B was equal to negative 1. So that's going to be plus negative x plus c is 2 over x squared plus 2x plus 4. So now we need to integrate each term. This second term is not integrated as easy, right? This is one of those similar to the ones in chapter 5, near the end of chapter 5, where you have to split them up depending on your du. This first one, the integral is really easy, right? That's just the natural log absolute value of x minus 2. But again, the second one here, what you do is you look at your denominator and let that be your u. And so your du would be 2x plus 2 or 2 times x plus 1. And so what do you have up here though? You have negative x plus 2. So I could bring a 1/2 out and accommodate for that, but I don't have the x up here that I need. I have the x. I could factor a negative out and make that x minus 2. So, but I want an x plus 1. Which if I factored the negative out, if you factor this negative out, then, and I'm just working with this term right here, if I factor that negative out, that becomes that, okay? The only problem with that is I want this up here to be equal to x plus 1. So I would need this right here with the negative. If I want that to be x plus 1, I'm really subtracting 1, right? Because I have this negative out here. But whatever I put up here, I'm going to have to add another part here. So, alright, let's go back to what we had. It's really negative x plus 2. But I want this up here to be x plus 1. That way it matches up with that. I'm really subtracting. I'm really going to have the minus here in the middle where this is. So if I have this negative out here, then that means I have a minus x and a minus 1. Well, I want it to equal a plus 2. If it's a minus 1, the only way I can get a plus 2 is if I put a 3 right here. Okay? So to put x plus 1 here like this, since there was a minus in front, I factored the negative out, and I want this to be x plus 1 so it matches up with that du, so that this will be a natural log integral. But to do that, I have to put a plus 3 right here. Right? Because if you distribute that back in, that'd be a negative 1, that'd be a negative x, negative 1, and plus 3 would give me plus 2. So that's how you have to split that up. Alright? This first integral here, again, is natural log. You just bring out the 1/2. So that's going to be negative 1/2 natural log absolute value x squared plus 2x plus 4. Now, what is this, though? That's the question of the hour. Do you remember that integral? You need to complete the square on the bottom. So this would be x squared plus 2x plus blank plus 4 minus blank. I put a 1 here and a 1 here. So this becomes, this denominator becomes x plus 2, I'm sorry, x plus 1 squared, and then you have plus 4 minus 1, so that's going to be plus 3. So this second denominator is actually x plus 1 squared plus 3. Okay? I integrated this first thing and got negative 1/2 natural log absolute value of x squared plus 2x plus 4. When I integrate the second term here, if this is the denominator, then it's an arctangent integral. Okay? An arctangent is, I have a 3 on top, but it's 1 over a arctangent u over a plus c. So integrate this. So I have this integral, I got this answer. This integral, I got this answer. And then this integral we said was going to be arctangent. So there's a 3 on top, and then 1 over a. What is a? This is a squared, so the square root of that is the square root of 3. So times 1 over a, so 1 over square root of 3, arctangent u, which is x plus 1, over a, square root of 3, plus c. Alright, so let's see what our final answer is. Because I had to integrate all three of these separately. So I have natural log absolute value of x minus 2 minus 1/2 natural log absolute value of x squared plus 2x plus 4 plus, if I rationalize this right here, that's going to be 3 square roots of 3 over 3, or just the square root of 3 arctangent. If I rationalize this right here, that's going to be the square root of 3 times x plus 1 all over 3 plus c.